you can't find any technical literature on a particular problem of interest, and like you kind of know what you want to do, but you just don't really have any of the assurance that what you're doing is correct. That's kind of what I'm going through right now with this whole seed ID thing. So what I ended up doing actually was I asked a friend of mine if they thought that this approach that I'm going to be taking here is reasonable, and yeah, they basically just reaffirmed everything that I thought initially about this, like generate the seed ID one character at a time, up to whatever length, and then, you know, hash it to a seed of the correct size. And yeah, this is actually why I've decided that this is probably going to be the blog post for this month, because this is not something that's, I guess, obvious. I mean, it's a sort of it's a problem where it's like, yeah, I mean, if you really think about it, this is probably like the best way to handle this sort of situation, and it is a kind of a specific problem. But if you are working on some kind of like randomizer or roguelike or whatever, it's I think this is actually a fairly common feature, or at least it's common enough that I feel it should be more readily available to like the documentation, I guess, or guides on how to do this kind of thing. So yeah, I mean, I'm probably looking in the wrong places. I mean, it might exist somewhere out there. It probably does. Oh, there goes the heater. But yeah, I just couldn't really find anything. It was sort of difficult to search for. So since this is going to be like the randomizer blog, I feel like I might as well include something about this, because it is a topic that people who are interested in making their own randomizers would probably want to know about. But yeah, it doesn't seem like it's going to be particularly hard. So I've started working on a bunch of stuff here, just kind of off camera, doing my usual, just listening to bossa nova while I try and work through code. It's I don't know, it creates a nice relaxing atmosphere, and like I find it a lot easier to work when I'm like listening to music like that. But yeah, I felt like actually doing a recorded update at some point here, just so that I don't leave this all hanging. First things first, I've strengthened the typing of my code a little bit. So originally the location IDs, they were integers. I decided to scrap that idea and just go with hard-coded location IDs, because eventually I'm going to want to like match on those and figure out like where to put items, I think. At least that makes sense to me for now. It might not make sense in the future if I decide I want to make it so that players can create their own maps and stuff. But since this is just mini-rando and I don't really have any plan to go that far, I'm going to leave it as it is. Because in that case, the items being hard-coded this way might not make sense. Although, yeah, it depends. Like, if I want to give the player, or whoever, the modder, custom game creator, the ability to control what items are in the game, then this won't fly either. So yeah, I feel like for now just stick to this. It's not a terrible change. If I do want to support being able to create your own maps and stuff later, not for this game, but for some, like, I don't know, game that builds off of this, then I can probably do that fairly easily. Oh yeah, and this block, I have plans for this block. Things will happen here at some point, but not right now. That might be for a future blog post or something, I don't know. So anyway, going back to the seed here. I moved a bunch of stuff around. Seed length now lives here. It doesn't live in the other modules. I haven't fixed the compilation errors related to that yet, so I still have to do that. The reason why is because I didn't want to have to keep reaching up to the module level just to grab the seed length. I felt like the seed length belongs with this sort of seed class, if you want to think of it that way. Because I realized that a seed is kind of comprised of two parts. There's the actual like seed bytes that you pass into the RNG to, actually seed the RNG. But then you also have a seed ID. And remember, like, when you're playing a randomizer, if you want to like share seed IDs, you're not going to be passing around like the actual seed around, the one that's used by the RNG. You're passing around this like 10-character string that has like 36 different possible combinations. And I kind of liked how that's done, because, well, that's how it's done in most other games I've seen. You just have like a 10-character string with 36 different combinations for each character. So I'm gonna basically do the same thing. To me it makes a lot of sense. So I've created this seed struct, adding this generate seed sort of constructor almost. It's a little bit more complex than a constructor, I would say, but yeah, it'll get the job done. And so to start, we're going to actually look at the RNG crate again. Rand crate. I keep coming back here because the documentation is it's very helpful, and that's good. I like it when documentation is helpful. It's a lot better when documentation isn't helpful, which is unfortunately the case in a lot of ecosystems. The Rust Rand book. Wow, I can't believe they actually have an entire book dedicated to this. Oh yeah, they definitely do. A lot of people are writing actual books for their crates, and I think that's actually kind of cool. Like, you don't really see that a lot in other languages, I find. I don't find entire books dedicated to, like, your dependencies. You might find books dedicated to things like, I don't know, like Angular and stuff, but like frameworks. But just to like the RNG dependency, like, that's cool. Anyway, I wanted to do like a gen range, but I can't remember what I was trying to do. I know that gen range exists. What if I look here? If I use this, maybe that'll work. I don't know. Yeah, gen range is here. So I could probably just go thread rng.genrange 0 through 36, and I could just do that like however many times. I think that makes sense. So we're gonna do exactly what they've done there. What was it? It was thread RNG and also RNG, of course. Alright. And we want to do this 10 times, or ID length times. And that'll be turned into a string through some mapping. So it's a little more complex than just, yeah, generate the string. Like, what I'm going to do is generate a bunch of numbers between 0 and 36. Of course, end of range exclusive. And then I'm going to do a mapping of those values to a string. So it's not going to be a map because the string is obviously technically not a collection, even though it's sort of a collection. It's a collection, but not a collection in this context. I don't think you can treat a string as like a collection of chars, but I'm sure that you can like join them or something together. Like I wouldn't be surprised if there was some way of doing that. Actually, is there a way to do that? If you have an iterator, maybe. Yeah, I'm certainly thinking the iterator approach might be helpful here. And then what you want to do is you'd want to hash that that string to whatever seed length, and then use that as your seed. That is the general algorithm I'm going for here. It's fairly straightforward, but yeah, I could see that certainly catching some people off guard if they are like new to programming and they're trying to do something like this and they don't realize that there's a bit of complexity involved here. So okay, this is going to be a little bit weird because I'm going to be generating 10 values. And that's going to cause this thing to mutate every time. So map is not really the best construct here, I think. I could possibly do like a for each. That might work. Yeah, I'm not actually sure how you'd like generate n values into like some kind of array or something, you know? Because it's kind of tempting. Fill dest entirely with random bytes. Oh, okay. Huh. Well, I don't really want random bytes. Huh. That's kind of cool. Okay, there's some nice, some cool stuff in here. Huh. Shuffle is deprecated? That's interesting. Slice random shuffle. Okay. That seems kinda... That definitely seems kinda new to me. So they're deprecating shuffle. That's... Oh boy. I'm gonna have to actually change to use slice random shuffle instead then. Pretty soon, I think. Let's sample iter. Sounds kind of good, but I'm not sure. Here's an iter that generates values using the given distribution. Oh, okay. Yeah, okay, I see. Alphanumeric. Oh, okay. Hey, that sounds really useful. Do you see that? Sample iter alphanumeric. Take 7, collect. That sounds exactly like the kind of thing I would want to use. What's this? Sample iter die range. Oh, uniform inclusive? 1 to 6? Yeah, okay. Well, that's super nice. If I can do that. Alright, yeah, just take a look through at the documentation. Figure out what your round number generator is capable of, because it might actually just save you a lot of time. Because this sounds exactly, well, no, this one's what I want, I think. Alphanumeric. Can I see what that is exactly? Where did I get that from? Alphanumeric comes from distributions. So where do I find that? I want to find rand distributions. Here we go. Let's open that in a new tab. I have a lot of tabs open right now. I should start closing stuff soon. Alright. Convenient functionality. Yep, it sure is. This is distribution used by RNG-gen and represents the default way to produce a random value from many different types. Yep, okay. Uniform range. Okay. Alphanumeric. Random letters and numbers of the char type. In contrast, standard may sample any valid char. Is it weird that I call it a char when it's, I mean, a character? So it should be like care or car? Pronunciation of these kind of like abbreviated things is weird. It's like either you butcher it or you don't. But it sounds weird. Alphanumeric. That would be... Oh, okay. Uniformly distributed or the ASCII characters. Lowercase a through z, capitals a through z, and 0 to 9. Okay. Not quite what I thought. I wonder if you can like define your own like your own distribution, or I could just do like a mapping. I don't have to go with this. That's pretty, yeah, that's true. I don't have to go with an alphanumeric. I mean, it would have been nice if it didn't do the lowercase letters, because I kind of don't really want those. I feel like that's just going to add complexity for no reason. So I think I am just going to try and map it. I'm glad I looked up the definition of alphanumeric in this case. Actually, I want to look at alphanumeric just to see if there's anything else here. Yeah, you can impl distribution. It's interesting. Can I see the... Okay. Oh, you can even look at the source, that's right. Yeah, let's just take a look at this. I'm not actually sure if I should do this now that I'm thinking about it, but well, whatever. How bad could it be? This is... Oh, okay, it's down here. That's weird. What's this? Oh, it looks like it it took the code from up here that was supposed to appear here. I entered the line numbers up here, but the actual code that would correspond to that is down here. That's kind of unfortunate. Oh, these unsafe. Oh, huh. Okay, maybe I don't want to implement my own. Kind of don't really want to be trying, I don't really want to play with unsafe. I know that unsafe, well, I've learned a little bit more about unsafe. Listened, I guess? Yeah, listened to the most recent New Rust Station podcast episode thing. And I know the 4 things that unsafe allows you to do. I still don't want to touch it. I'd rather just not have unsafe at all in my code if I can avoid it. Because, like, unsafe is one of those things where like already a lot of dependencies and stuff are using it. The standard library uses it quite heavily, so like, if you can't write most of your code or all of your code in unsafe or in safe code, then it kind of defeats the purpose. Like, you lose a lot of those safety guarantees, I feel, because now you have this potentially unsafe code. Even if it's just a little bit, like, just knowing that you've absolutely banned unsafe code from your code, you can be, like, 100% sure, no doubt whatsoever, that any weird, undefined behavior you run into is not your fault, but the fault of one of your dependencies, at least. I mean, not that that's necessarily a good thing, but it at least shifts the blame away, and I guess that peace of mind is what matters, maybe? It's a weird way of thinking, I guess, but that's how I feel. I don't know. I'm gonna do a gen range, and we're gonna do some mapping. That's the smart thing to do in this case, because I don't want to I don't want to do the thing that with the unsafe. Unsafe is scary, and you should be scared of it. I just feel like I've seen so many stories of people like using a bit of unsafe, and then it turned out that bit of unsafe was unsound all along. Like, it feels like it's too easy to accidentally write unsound unsafe code rather than safe unsafe code, which is kind of oxymoronic when you really think about it. I know that they've been thinking about using a different name for unsafe, but you know, what are you gonna call it? Potentially unsafe? Because it's kind of verbose, no matter how you try and slice it. I've heard some people say that they want to make it into a trust block, and I think that's kind of silly. It's like, oh man, this trust code was actually untrustworthy. Haha. So yeah, I just want to do the sample iter thing. I think it'll create an iteration or an iterator. Yeah, it does create an iterator, and then I can do stuff with it. So I'll just go with the standard distribution from some kind of range. Yeah, I'll do this uniform distribution thing. Where's my cursor? There it is. Distributions. Standard. And then we can just create a standard, yeah, like this die range kind of thing. Do I want to do inclusive? It doesn't really matter. Yeah, I'll just make an inclusive range. It doesn't... not a big deal to me. Let's see. Oops. Was it uniform? That was called uniform. Uniform distribution. What's standard distribution? Is that... oh wait, standard distribution is... oh. What is standard distribution? Is that different from uniform? Is that the one with the bell curve? I feel like that might be the bell curve one. Well, now I'm curious, because I don't want to just do dumb things. Okay, I don't know. Okay, standard distribution seems to... Oh boy. Okay, this definitely doesn't seem like what I want. This seems like this seems a lot more complicated than I need it to be. I see there's some SIMD stuff going on there. It's interesting. Yeah. Oh boy. Let's just yes. Let's use the uniform distribution instead, since that one I think will behave the way that I want it to. New inclusive. We'll just go stop that. 0 to 35. Then I'm gonna map it. Map. I guess ID. Map to ID. Yeah, maybe that makes more sense. And we'll just create what? I think what we're going to do is we're going to take a... what are these values that are coming back, actually, now that I think about it? Oh, what was I looking at now? Nope, that's not what I was looking at. Sample iter, here we go. So they do this new inclusive range. Sample iter, and they pass in a reference to the range. And that seems to be an iterator, which I want to turn into some kind of array. Or array slice. Or something, you know? We just want it to be a something. Yeah, okay. Oh, wait a minute. Huh, so this will just keep generating values. Okay, I see. Infinitely until eventually it is a 6. I think. Yeah. Huh. So this is how you can do like an infinite number generator type of thing with the given distribution. Alright. I don't know what's the type of these values, or the values that are being generated. Like, are those going to be U size, or are they going to be something else? I don't know. I guess we'll find out. I would hazard a guess it's going to be U size. So I'm going to take a U size value. And we're going to produce a U size value, I guess. Wait, no, we're not going to produce a U size, we're going to return a character, right? Yeah. And we're just going to take num. Oh, that's Scala syntax. Careful. Don't mix up your syntaxes, kids. I mean, I guess it's not such a bad thing since the compiler is going to catch it, but in other languages that don't have compilers, or well, you know, like languages that aren't really checked at compile time that way, you have to be a bit more careful. This seems like a very bad approach in some ways, but I think it'll be fine. I almost feel like there should be a more elegant way of doing this, but I don't think this is actually the worst thing. No, I don't have any constraint on these values. So that's a thing. So if it's past 26, then it won't really know what to do. I guess I could modulo it. I could do like a mod, whatever. I don't think that's the worst thing in the world. Mod, what, 26? No, 36? Yeah, so if it is 36, it'll be 0. And if it's 35, then we're okay. Yeah, I could make that a constant, actually, but I'll do it later. There's a smarter way of doing this, I realize. I think. Actually, I'm not entirely sure about that. The smart way I was thinking of was just like mapping it based on, like, you know, the way that ASCII does it, because I'm pretty sure those values are also ascending. But I don't know about like numbers. Although I guess I could just like shift everything up like above a certain range to a different set of values, and then yeah, I could have done it that way. Yeah, here I am doing this. Alright, so now the rest of these values will just be numbers. Does that make sense? Yeah. Just do this. Oops. I guess there's the risk of mistyping things, if anything. Alright, that should be everything. Or at least all the possible values. Wait. That's not right. Aren't there supposed to be like 36 values? Am I going crazy? I'm going crazy, aren't I? I thought there'd be more values. Or no, I thought there'd be this many values. Because there's 26 letters in the alphabet, and then there's 10 digits, right? Or am I going crazy? I might be going crazy here. Because there's definitely 10 digits. I know that much. Yeah, and I get 38. But I thought there were only 26 letters in the alphabet. Did I repeat some? Okay, I counted 36. I must have skipped a digit somewhere. That's the only explanation I can think of. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is why this is not a very good method. I am starting to realize this. This is not a very good way of doing this. Oh. No wonder. I suddenly went to... Yeah, okay. Wow. Don't think this was the best way of doing it. No, not at all. There we go. I fixed it. I wish I could have had like some kind of enforcement that the value would be, you know, between 0 and 35 inclusive. If I had that kind of enforcement, I think I'd be a lot happier about this. But I don't. I don't have that. I could add like a debug assert, I guess, to try and make sure that never happens. You know, I think I'm gonna do that. Because I'm not sure. And I think I will try and leave this in here. Actually, no, that doesn't make sense. So I have another problem here. This is going to complain about non-exhaustive patterns, I'm pretty sure. I need a catch-all case. What that catch-all case is going to do is probably return... Oh boy. Yeah, on second thought, maybe this should be an option. This might be better off as an option. Up to ID char, yeah. I'll just do an option char. I'm more comfortable with that. Also, is it lowercase or uppercase? I actually don't remember. I thought I saw the type somewhere around here, but that's probably... Oh no, it was in there, the distributions, that's right. Distributions. And I think it was alphanumeric, wherever that is now. Yeah. Oh yeah, no, it is lowercase char. Okay. I'm gonna return an option char. That means I'm probably going to wrap all these in some instead of just, you know, nothing. So that'll be fun. So I've had a result. Result might be more appropriate. Because, like, what are you gonna do with a character? You're probably not gonna want a character. Right? Actually, I don't need to do that. I'm being silly. Am I being silly? But I have to return something here. I was thinking I could just return like the character and then just be like, oh yeah, wrap it in like an OK at the end. But now I don't know. I think I want to use a result here. I want to return an error. Actually, you know what? For now we're going to do this, and then I'm going to do this. This is not a good idea. I should not be doing this, but here I am doing it anyway, because I just want to move on quickly from here. Greater than or equals 0, and num is less than equal to 35. 35. Yeah, so we want to make sure it falls in that range. If it doesn't, it will never hit this case anyway, so that's okay. Because we have this debug assert here, which is gonna like crash the program. But I don't want to crash the program. I wanna handle that properly with a result. So I'll do that later, but for now this will do. Yeah, definitely not the way I wanted this to go. Alright, you, where are you? Goes here, right. Sample iter. Yeah, I'm gonna do that. Was it thread, RNG, sample iter, give it a reference to range, we're gonna map it, we're gonna actually take, the first does it make sense to map first and then do the take? I think it makes sense to do the take first, right? Actually, no, it's lazy anyway. It shouldn't make a difference. We're going to take the first 10. By 10, I mean ID length. Then we're going to map. Alright, we're doing it. We're busting out the combinator chaining again. Because we're pro. We know what we're doing. Yeah, we're going to bust this out here. And we're going to map them all using our new map to ID char. Oh, wait. This is not Scala. You can't do that. It's not Scala. C, yeah, map this thing to that. Okay. I'm gonna be explicit about that since it's complaining. Then we're gonna do a yield. Well, I wasn't complaining about that, but the compiler couldn't figure that out. I just wanted to be explicit. Wait, what am I doing? That doesn't make sense. This needs to be a U size. Oh right, yeah. I didn't even know if this was going to be a U size. Well, now I'm saying it is U size. It doesn't really have to be U size though. It could have been U32. Yeah, I could just go with like U32 or something, maybe even U16. Does it fit in U8? I don't think U8 would work for this. I think this is too big for U8. I can't remember how much 8 bits is though. Actually, I think 35 should fit in 8 bits. 8 bits is pretty big. But will it be able to handle that, I wonder? Because 8 bits is like 256 different values, I believe. Yeah, that's right. A byte can hold 256 different values. So let's see if it's able to do that. And collect into a string. Okay, right. I was starting to like lose it there. I was just like, what am I doing? I don't know. And there we go. We'll just collect it into a string. Just like that. Okay, so there's our seed ID. Oh, actually, you know what's better? Actually, I'm not sure if that's better. I was about to do something kind of silly and wrap this entire thing in seed and then just pass this in here so I didn't have to name it, but I don't think I'm going to do that anyway. No, I kind of prefer doing this anyhow, because this looks just a little bit nicer. Alright, seed bytes. So this one is going to be a bit more tricky. Now we're going to actually do the hash. Yeah, we're going to actually have to hash this now. Yeah, I wish there was a better way to enforce these constraints here, but I don't think there is actually a better way. Like, I'm probably gonna have to go switch from the debug assert to result instead. That's the only thing I can think of. Because that has to be computed at runtime. So seed bytes is going to be this. Yeah, I'm making extensive use of the new type pattern here because I want to make sure that what I'm passing in later on to my other functions is definitely of the correct type. You can like if you can type everything and the language lets you do it with as a zero cost abstraction, like why wouldn't you? So let seed bytes equal, I don't know. I have to somehow hash that ID string now. To a certain size. That's going to be kind of tricky, isn't it? Yeah, how do I do that? Let's look up hash rest. Generic way to compute the hash of a value, yep. Yep, derive hash, of course. I think string should already be hashable. Doesn't make sense for it not to. Ah, yes, calculate hash. So take in some object that implements the hash trait and then call hash on it. Okay, you know what, that makes a lot of sense. And then we'll get some kind of value out. It's not finished, okay. Default hasher. That's U64. And I want to hash it to something of size 256. Or I want to hash it to like an array. I guess I don't have to hash it to an array, though. If it doesn't make sense to do it that way. Oh boy. I don't know. Hashing an arbitrary stream of bytes? Is that what I think? Ah, here we go. Yeah. I think. Oh wait, I'm not sure actually. Yeah, I don't know about that. What is hasher.finish going to return? U64, okay. Yeah. Something tells me I'm not really sure what I'm doing. You write single byte into the hasher. Huh. So every time you finish, you'll... You always get a U64. Okay. Not what I thought it would be doing. I guess I might have to implement my own hash. Maybe. Maybe. Because that takes a mutable reference. Okay, tell me more about this. Hash on each field. Yep, that makes sense. Implement hash yourself. Yeah, I sure can. Oh yeah, it takes a mutable state. So it does require a hasher. And then when you call hasher.finish, it'll give you a 64-bit integer. Okay. Alright, there's some food for thought. Because yeah, we only go up to U128, so you're not gonna be... How do you hash something to not a U64? That's what I'm kind of curious to know. I mean, I guess I don't need to be... I guess I don't need to be like 256 bits. But it would be nice to know, like, how do you do like an arbitrary size? Because I want to know the answer. Oh, future. Do we have futures in standard? Pin. That seems new as well. I know there's like a pinning API that people were talking about a little while ago, where you can like mark stuff as immovable. Okay. Yeah, I'm starting to wonder. Write some data into this hasher. But then I can never like finish. If I finish it, it's always going to produce U64. Is that like, oh, am I reasoning about this correctly at all? Or what? What am I doing wrong? I feel like I'm not doing this correctly. Yeah, I can use a map data of arbitrary size to data of fixed size. So... okay. I don't really care about that. Oh god, there's so much stuff about hashing here. There's so many different ways to do hashing. Okay. At this point, I don't really know what I'm doing, so I think I'm gonna call it here. I'm gonna have to do a little bit more research to figure out what I want to do from this step onward, because, yeah, I mean, I could just take the easy way out here and just go like dot finish, use a U64 as a seed, done, and that is really tempting. But I do also want to know if there is a way to, like, because the way that the Wikipedia article states it, sounds like you can just do it, you can map it to like some arbitrary size thing. So I'm wondering how you do that in Rust. So, yep, I'm gonna leave it here for now, and I will either, yeah, I'm probably gonna continue working on this next time because I don't want to go back to the prefab stuff just yet.